Okay. So in last class, I have given you one homework. है ना? So first I will go for that problem. And then today we will just try to solve some problem based on pulley questions as well as a pseudo force question. Okay. So these two things we have to just try to understand this particular thing. Okay. So let's try to go for a last problem. But before going to last problem, let me solve a one very trivial question. That is very trivial. And then we will go for the last one. And what is this particular trivial question? This is a rigid wall. So this is a rigid wall. You have rigid wall. And there is a some mass M attached to this wall. And we are just putting some force F. So if we are pushing with the some force F, my question is that what will be minimum force such that this particle will not slide on this particular surface? So this is very interesting one. So you have to just give your F such that this block is not going to slide. Okay. So, okay, I will ask you about the doubt. First, let me complete this thing. Okay.
Okay.
Okay. So F, so we are just pushing the F force into this mass M, and there is coefficient of friction. That value is equal to mu. So we have to find the minimum force such that this mass is not going to this mass is not going downward. So we have to talk about the minimum force. And obviously, if you will push it very hardly, it will never go down. If you will so that you have enough normal such that due to that enough normal, you have a frictional force that will oppose this particular weight of the particle. So let me give you first free body diagram. So what will be weight going to associate in this particular mass? That will be mg. Mg is the weight. And now just tell me what will be the direction of frictional force? So here you have to use the coefficient of friction and you have to ask the question, if there is not any friction, then what is going to happen? If there is not any friction, then this block is bound to go downward, isn't it? So obviously, then frictional force will go into this direction, that is your frictional force. And for the limiting case, your frictional force must be equal to M into G. Then only this block will remain stationary with respect to this particular wall. And what will be your frictional force for the limiting case? Mu into N, isn't it? Mu into N must be mg. And what will be normal force? This is your N. So there is not any motion in this particular direction, in this horizontal direction. So this normal force is exactly equal to what? Force applied by the person. And that will be the minimum one. So we can replace it from here. So this will be mu into F is equal to mg. So F will be mg by mu. So this is a very fundamental question, very trivial, very simple question. Why I have solved this question? Because I want to go for the next one, which is very interesting, and where we just want to see whether we have solved it correctly or not. Okay, so this is very famous result, and you have to just you can remember this result, that when your mg is equal to frictional force, then this is not going to fall down, and this frictional force will be associated to this F, because this F is actually nothing but equal to what? Normal force. So this is my problem. Now let's try to go for next problem. Next problem जो हम लोगों ने आपको homework में दिया था, उस problem के बारे में बात करते हैं. Okay, let's try to go for this. This time, here is some finite mass. What is meaning of this rigid wall? Rigid wall means there is some infinite mass. So why? If you are pushing it with a very high force, very large force, it is not going to move. But if there is finite mass, then the scenario is just going to change in a very different direction. So this is some mass M, And this whole surface, this horizontal surface is actually frictionless. And what we have to do, we have to just go for a small mass m. And now my question is that what will be the f minimum, the minimum value of f, such that this particle is not going to slide vertically with respect to capital M. This is very interesting. So you have to just do this particular problem. Now, hence this is frictionless. Then hence this is frictionless. Whatever with the force we are going to apply, irrespective of it, this is going downward or upward, it will move in a horizontal direction. Are you getting my point? यहाँ पर कोई confusion है? Yes?
Please
Okay.
explain once again.
Sorry, बताइए.
Please explain once again.
Please explain once again. मैं क्या कह रहा हूं? If I am giving you a some horizontal force, hence there is not any friction in this horizontal plane and this particular mass, then whatever with the minimum force, these two masses are bound to move towards right. Are you happy with this argument or not?
Yes, sir.
Okay, good. Now, can I say this force must be equal to m plus m into a? Are you happy? होगा ना, क्योंकि ये दोनों को हम एक बॉडी की तरह ट्रीट कर सकते हैं एंड दे कैन मूव इन दिस पर्टिकुलर डायरेक्शन. नाउ लेट अस ट्राई टू गो फॉर अ स्मॉल मास. स्मॉल मास को अगर आप लेते हो, व्हाट विल बी ऑल अबाउट स्मॉल मास? You have frictional force in this direction. Sorry, you have applied force in this direction. This is your small mass. You have weight into this direction. Yes, mg. And what will be your normal force? Obviously, this mass in when you are pushing this particular mass, a small m, then a small m will push to capital M, and capital M will also push to a small m from the Newton's third law. For every action, there is reaction. Action and reaction will be act onto two different body and in different direction. So yes, that reaction can be written in term of normal force. And again, what will be directional of frictional force? The direction of frictional force is Fr. Now, again, this body is not going to move in this particular direction. So, this body is not going to move in a vertical direction. That means my frictional force must be equal to mg. And here, this frictional force is equivalent to what? Again, mu into n is equal to mg. Now the question is that what will be this n? N की value क्या होगी? This is very interesting. So here you can find that f minus n must be equal to small m a. Isn't it? होगा ना? Because this is just moving in this direction with acceleration a. So now look at here, due to this acceleration, we have a normal force, and this normal force can be calculated. Now we can calculate the value of a from here. Calculate कर सकते क्या? Yes, we can calculate. So this f minus n must be m into a, and this a is nothing but f upon m by capital M. Now, the normal force is given by F minus mf by small m by capital M. This is my normal force. And now we will put this equation here. Now we will put this equation here. So when you will just try to put this equation here, then what you will get? You will get mu, and now your F is basically, normal force is F 1 minus m by m plus m, and that value is equal to mg, and this value is mu F, and this value is equal to what? M by m plus m, isn't it? And this value is equal to mg. And now you can find the value of F. The value of F is equal to mg by mu and you have m plus capital M. One is capital M, okay? M plus capital M by capital M, okay? Now look at the analysis part. This is very interesting. So this thing can be written as F is equal to, इसको कैसे लिख सकते हैं? ऐसे लिख सकते हैं ना? F is equal to mg by mu, and here this will be 1 plus small m by capital M. And now look at, we can check whether we are correct or not. If this capital M is very large in compared to small m, or if you will say this capital M tends to infinity, then what will happen? This value is equal to what? 0, isn't it? You can check it. You can check it. So if my capital M is very, very large, then F is equal to nothing but mg by mu, and you have this particular equation. Everyone is comfortable?
Yes, sir.
है ना? And now you can see this is exactly same answer you are getting from here, isn't it? When we will make it rigid, that means we are not going to move this surface, then your result will be exactly matching with this one. And look at the very fundamental thing here. The normal force is going to change due to this particular acceleration, isn't it? Initially your normal force will be F, but hence it is moving into right side. So due to that fact, this normal force is going to change, and so why the whole answer is going to change. So this is one of my favorite question. Still, this is not very tough question, but yes, it is a very much fundamental question where you can learn the effect of normal force, and you can see how this acceleration will take part to influence the normal force. Here, the normal force is exactly equal to F. So you have to compare these two problem in every time. So what you are getting this normal force is F here, but when this is moving with some acceleration, the actually normal force is going to decrease, isn't it? यहां से देख लो, है ना? So this is a wonderful problem. चलो, now what was your doubt? चलो बताओ, किसी स्टूडेंट का डाउट था, बताइए.
यस सर. सर जो हमने
बताओ.
लास्ट सेकंड क्वेश्चन किया था ना कल.
लास्ट क्लास में कौन सा, क्या सेकंड थर्ड नहीं, बताओ कौन सा क्वेश्चन था?
ओके सर,
ये
जहाँ पे
मुझे याद नहीं रहता है.
ओके सर, जो हमें क्वेश्चन TIFR में आया था, tan थीटा का वैल्यू निकालना था हमें. तो हमें दो केस मिले थे. tan थीटा इज ग्रेटर देन 1 प्लस म्यू बाय 1 माइनस म्यू. एंड हमारे सेकंड केस में हमें रिजल्ट मिला था tan थीटा इक्वल्स टू tan थीटा इज लेस देन 1 माइनस म्यू बाय 1 प्लस म्यू. तो देन हमने जब उसे प्रोहिबिशन ऑफ मोशन के इक्वेशन में लिखा, तो शायद हमने आगे पीछे लिखा है क्या?
नहीं सही लिखा है. आप देख लो, जो बड़ा वाला होगा बाद में होगा, जो छोटा वाला होगा पहले होगा, तभी तो रेंज पता चलेगा.
हाँ सर, मैंने जैसे वीडियो को वापस से देखा ना रिकॉर्डिंग, तो हमने थोड़ा वो लिखा है आगे पीछे.
वी विल चेक इट, देख लेंगे, ठीक है? ओके
सर, एक और डाउट था मेरा.
बताइए.
सर, जो थर्ड क्वेश्चन किया था हमने, जिसमें हमें मिनिमम वैल्यू ऑफ फोर्स कैलकुलेट करना था. सर, उसको हमने tan थीटा का वैल्यू 1 बाई म्यू निकाला है. तो वहां से आपने sin थीटा और cos थीटा कैसे एज्यूम किया? मैं वहां फंस गई थी, और आपका आवाज
क्यों sin थीटा cos थीटा क्यों नहीं निकलेगा? b बाई p इज इक्वल टू, यही तो tan थीटा होता है, तो sin थीटा की वैल्यू क्या होगी? वहां से नहीं निकल जाएगा? अरे भाई, आपका ये तो क्लास 8 की चीजें हैं, ये सब थोड़ा सा याद रखना पड़ेगा. अगर tan थीटा p बाई b होता है, तो cos थीटा क्या होगा बताओ? b बाई p स्क्वायर प्लस b स्क्वायर रूट अंडर, ये नहीं होगा? ट्रायंगल रूल भूल गए? हेलो
सर, am I audible?
यस यू आर ऑडिबल. भाई ट्रायंगल रूल भूल गए क्या?
तो याद है.
तो यही तो किया है ये, और क्या किया है?
ओके सर.
ठीक है.
ओके.
और सेम चीज हमने किया है ना? tan थीटा की वैल्यू, अगर sin थीटा की वैल्यू है तो cos थीटा निकल जाएगा, tan थीटा निकल जाएगा, सारा निकल जाएगा. एक बार घर में जाके प्रैक्टिस कीजिए इसको, ठीक है? ये ट्रायंगल रूल याद है ना? ये B होता है, ये P होता है, ये H होता है. आर यू गेटिंग माय पॉइंट? So
Yes,
cos,
sir.
अगर ये angle theta है, what is your cos theta? This by this. What is your sin theta? This by this.
Perpendicular hypotenuse.
हाँ
Perpendicular by hypotenuse.
हाँ, तो ये सारा चीज तो आपको यूज करना होगा ना, ये मैं थोड़ी यहाँ पर बता पाऊंगा इतना. ओके, चलो लेट्स गो फॉर नेक्स्ट सम बेसिक पुली क्वेश्चन. ओके, so now this is very trivial to you, but initially you have to solve the trivial problem, then only you can go for non-trivial problems. Okay, so let's try to go for this particular problem. So this is one of the very famous question, and I think everyone has encountered in their life. The first pulley question is this Atwood machine, isn't it? यही पढ़े हो ना? This is M1,
Yes,
and this
yes,
one
sir.
is what? M2. This is one of the simplest system of your codes. Okay, and this is the direction of G, and it can move downward or upward direction. Okay, now how you will solve it? In general, 90% people will just write, okay, there is M1G, this value is equal to tension, this value is equal to M2G, and this value is tension. Suppose this is going downward, so and I can take this one as acceleration. So how you will write? M2G
Minus T
minus
equals to
tension is equal to what? M2
A.
A, ये लिखते हो,
Yes, sir.
and second आप क्या लिखते हो? T minus M2 M1G is equal to M1A. क्लियर है ये? ऐसा ही तो लिखते हैं ना?
Yes,
Now
sir.
my question is that how do you know that this A and this A is same? Number one. And first, if you are taking this sign as your positive or positive sign, how you are getting it negative here? अगर mg का साइन आप पॉजिटिव ले रहे हो इसके लिए, तो इसके लिए भी तो आपको पॉजिटिव ही लेना चाहिए. This is correct. This is correct. This is not wrong. Don't worry. But you will just visualize this thing in a very nice way. आप क्या visualize कर लेते हो? आप ये visualize कर लेते हो that if M2 will move x distance, then M1 will move also in opposite x distance, isn't it?
Yes, sir.
यही आप visualize कर लेते हो. But if I will solve this problem in a straightforward manner without visualizing anything, then how I will solve it? Look at this is very interesting. I just assume that its acceleration is a1 and its acceleration is a2, and this is my mass m1g, m2g. So first equation is m2g minus tension is equal to m2. Sorry, this will be a2 कर दो है ना? इसको a2, इसको a1. m2 a2, and for the first particle m1g minus t is equal to m1 a1. Why? Because I have make my sign convention that this direction is my positive. So for this can be also positive. But how many equation is there? 2 equation. But how many variables are there? 3 variable. T, A2, A1. So what you need? You need one more variable to solve this problem. है ना? And
Yes, sir.
that variable can be determined by equation of constraint. So what will happen? You can see that this distance is, let's say, x1, and this distance is, let's say, x2, and let's say this distance is r. So this value is pi r. So what I can say x1 plus pi r. This is your pi r. Okay. x1 plus pi r plus x2 must be fixed, because the length of this string is always going to fix. Isn't it? होगा ना?
Yes, sir.
And
Yes,
from
sir.
here, I can mathematically determine that x1 double dot plus x2 double dot must be equal to 0. That means x1 double dot is nothing but minus x2 double dot. So a1 is equal to minus a2. And then what we can put? I can put a1 is equal to a and a2 is equal to minus a2. You can just put it, isn't it? And you will land at this particular equation. Put कर सकते हैं ना? उल्टा भी कर सकते हो. You can put a2 is equal to a because you are just assuming this is your positive direction. So a2 is equal to a, then a1 is equal to minus a. And now you can put it this particular equation. So ये equation फिर से आपका क्या मिल जाएगा? Then this equation is m2g minus t is equal to m2a, and second equation is m1g minus t is equal to minus m1a, because a m1 and minus a you can just put minus a. And now this equation can be written t minus m1g is equal to m1a. So now you can easily solve these two equations and you can find either value of tension or you can find the value of acceleration. कर सकते ना from here?
Yes, sir.
Now this is very trivial. आप बोलोगे कि अरे इतना करने की जरूरत क्या है, इसका कोई रोल तो है नहीं. But look at the next problem. When you will go to the next problem, then you will visualize that okay, how important is this particular equation of constraint? This is your equation of constraint. Okay, so let's try to go for some non-trivial problem where we can discuss all about equation of constraint. इसके बारे में हम लोग discuss कर सकते हैं. Everyone is comfortable up to this?
Yes, sir.
Okay.
Yes, sir.
Okay. Now, let us see what is going to happen. This is very interesting and this is one of the very fundamental problem. So, this is one pulley and here is mass m1 and here is another mass, let's say m2, and this is our surface. And the acceleration of a1 is equal to m1 is a1 and acceleration of a2 is m2. And we can just assume whatever be the direction of anything. Okay, we can assume that it can be easily, if you are using the direction of equation of constraint, then you can easily write this particular the equation of motion, and finally you will get the correct answer. So it is not necessary that you have to think unnecessary that which will we go downward, which will we go upward. Why? Because now this is not rest. This is not rest. What is going to happen? This whole system is moving with acceleration a0. Are you getting my point? ये पूरा का पूरा
Yes, sir.
सिस्टम a0 के acceleration से move कर रहा है. Then it is very difficult to see that which particle is going downward and which particle is going upward. Are you able to judge very easily? अगर यहां तक तो जज कर भी सकते हो. सपोज इस तरह के प्रॉब्लम आ जाएं. Suppose this problem will come. Then suppose this is m1, this is m2, this is m3, this is m4, and suppose मैं इसको fix भी कर देता हूं. Can you judge which one will go up, which one will go down, what will going to happen? Can you easily visualize this thing? क्या possible है?
No, sir.
Never, never. So why equation of constraint is very important? Are you getting my point? So आप arbitrarily, suppose this whole system is moving in a naught acceleration. Whole system is moving. So what we can do? Again, what is your equation of constraint? Your equation of constraint is this length of this rope is going to what? Fix. And let's say that value is L0 or L. Then what will happen? Let's say this distance is x1 because it is moving with respect to this surface. I cannot take origin with respect to this because origin itself is moving with the time. It is also going to change in every second. And this value is what? x2. ये value क्या है? x1 and x1. This value is what? x2. Everyone is comfortable? And let's say this value is what? x0. And now I can easily say this distance is nothing but x0 minus x1. Are you people happy? This distance?
Yes, sir.
Yes. What will be this distance?
Pi r.
Pi into r. What will be this distance?
x0 minus x2.
Very good. So that value is equal to x0 minus x2 and that value is equal to what? L. ये value कितना है? L है. Everyone is comfortable?
Yes, sir.
Everyone? Okay. Now what is going to happen? You can differentiate. Hence this length is fixed. Then what will happen? x0 double dot minus x1 double dot plus 0 because this is constant plus x0 double dot minus x2 double dot is equal to 0. And what is your next answer? The next answer is that x0 double dot is equal to x1 double dot plus x2 double dot by 2. Now you can see you can easily solve this particular problem, isn't it?
Yes,
है ना?
sir.
Because this A0 is given. This A0 is given. So now what you will do? You will just write the equation of motion. M1G minus T is equal to M1A1. Second equation you will write M2G minus T is equal to write M2A2. And you can write A1 or A2 in term of A0 and you can easily solve the problem. Isn't it? How
Yes,
many
sir.
variable is there? 3 variable. First, second, and third. This is given because this is moving with the A0 acceleration. It may be given that A0 is equal to, let's say, some G by 2. It can be given. So this is given. So how many equation? 1, 2. So this is my first equation. This is my second equation. And this is my third equation. And once you are getting this 3 equation, you can easily solve this equation. Are you getting my point?
Yes, sir.
है ना? So now you can see, मैंने कुछ भी नहीं देखा कि कौन सा ऊपर जा रहा है, कौन सा नीचे जा रहा है, मुझे उससे कोई मतलब नहीं है. I can choose anyone as my positive direction. And अगर उसका opposite आ जाता है, suppose M1 की वैल्यू 10 kg है, M2 की वैल्यू 20 kg है, so उसका opposite आ जाएगा, then that will be the positive direction. Are you getting my point? So you need not to worry about the direction. What you need to worry about the equation of constraint. Are you getting my point? है ना? So how you are writing this particular equation of constraint is very interesting. यहाँ तक clear है आप लोग का? Okay? So why didn't you solve this for homework? चलो solve कर लेना homework के लिए. Suppose A0 is equal to G by 2, then try to find value of A1, A2. निकल जाएगा ये? है ना? हो जाएगा?
Yes, sir.
Yes, sir.
Okay. So just try to solve this particular problem as your homework. Now come to this problem. Look at what will be equation of constraint into this problem. मैं आपको 2 मिनट का टाइम दूं, लिखोगे क्या?
Yes.
Okay. So suppose its acceleration is A1, its acceleration is A2, its acceleration is A3, its acceleration is A4. So what will be your equation of constraint in this particular thing? Just try to write. और what will be your relationship between A1, A2, A3? यही तो निकाल रहे हैं. We are just trying to find what is relationship between A1, A2, A3 and A4. Okay, this is your A4. Anyone? कोई दे सकता है आंसर? What will be answer?
सर
हम्म.
सर वो जो दो पुली बना हुआ है उसका
हम्म.
एक्सेलरेशन कितना होगा?
उसका कोई भी एक्सेलरेशन आप देख सकते हो.
ओके
उसका कोई भी एक्सेलरेशन दिया हुआ नहीं है. ये तो डिपेंड करेगा कि ये दोनों कैसे ऊपर नीचे जा रहे हैं. Isn't it?
ओके सर.
लेकिन ये पक्का है कि जो इसका एक्सेलरेशन होगा वही इसका भी एक्सेलरेशन होगा, बट इन अपोजिट
Yes, sir.
डायरेक्शन. है ना? एंड दीज आर मासलेस पुली, सो डोंट वरी.
सर
हम्म.
सर मैं अगर मैं ऊपर वाला उसको ए नॉट मान लूं तो पहला
हम्म.
वाला तो आ रहा है ए नॉट इक्वल्स टू A1 प्लस A2 बाई 2.
A1 प्लस A2 बाई
A2 बाई
2. वेरी गुड. और सेकंड वाले का?
सर वो A3 प्लस A4 बाई 2.
वेरी गुड. सो आप यहां पर ये एज्यूम करोगे, सो जस्ट यू कैन एज्यूम समथिंग लाइक दिस. सपोज ये आपका M1 है, दिस इज योर M1 एंड दिस इज योर M2. ओके, सो ये पूरा का पूरा सिस्टम आई कैन एज्यूम दिस इज मूविंग अपवर्ड विथ एक्सेलरेशन A0. तो लास्ट का प्रॉब्लम हो गया ना ये, isn't it?
Yes.
So from here we can write A0 is equal to A1 plus A2 by 2. लिख सकते हैं. इसकी एक्सेलरेशन A1 है, इसकी एक्सेलरेशन A2 है. Now, so this is for this particular set. What about this particular set? The second set is something like this. इसका एक्सेलरेशन क्या है? A3 and this is A3 and this is your A4. Now, if this whole system is moving upward direction, then this whole system will move in downward direction, isn't it?
Yes, sir.
Why? Because this rope is also fixed. ये rope का भी तो length fix है, isn't it? And this is nothing but the same as the Atwood machine, the simplest form of the Atwood machine. So obviously, if this is moving with the A1, A0 acceleration, then this will go downward with the minus A0 acceleration, and that value is equal to what? A3 plus A4 by 2, isn't it? And from here,
Yes.
you can make a conclusion that A1 plus A2 by 2 must be equal to minus A3 plus A4 by 2. And from here, you can have a very beautiful conclusion. A1 plus A2 plus A3 plus A4 is equal to 0. Yes? हो जाएगा ना?
Yes, sir.
Okay. So, and इसके अंदर टेंशन क्या होगा? T1. इसके अंदर टेंशन क्या होगा? T2. So you have to write the all number of variable must be equal to what? Number of equation. And
Sir,
एक
T1
जो
और T2 भी सेम होगा.
and T1 and T2 भी
So
same
this
होगा,
same.
because this will be obviously, so this will be tension T, and this will be T1, this will be T2, this will be this will be T1 also, and this will be your T2, and this will be T2, and again you can find this T is equal to T1 2 times T1, and this T is equal to 2 times T2, so T1 is equal to T2, एंड यहां पर दोनों में टेंशन भी क्या हो जाएगा, दैट विल बी ऑल्सो सेम, क्योंकि इस पुली के लिए आप जब इक्वेशन ऑफ मोशन लिखोगे तो क्या लिखोगे, वी कैन एज्यूम दिस पुली इज मासलेस, सो यू कैन राइट T time T is equal to 2 times T1, and for this one you will write T is equal to 2 times T2, and from here T1 is equal to T2, and now you can solve the whole problem in a very nice way. Are you getting my point?
Yes, sir.
है ना, सॉरी
सर वो नीचे की पुली के लिए हमने टेंशन वो अप मतलब डाउनवर्ड्स क्यों लिया है?
अरे ये जो टेंशन का काम क्या है, खींचना, ये तो सिखाया था ना
यस सर।
भाई, टेंशन का क्या काम है, आप अगर ये टेंशन, इस पुली के लिए टेंशन किस डायरेक्शन में होगा बताओ, सपोज इस पुली के लिए लिख रहे हो, किस डायरेक्शन में होगा,
अपवर्ड।
अपवर्ड, अपवर्ड होगा तो खींचेगा कैसे जरा ये बताओ,
सर वो ऊपर वाला पुली के लिए ना,
इस वाले पुली के लिए डायरेक्शन क्या होगा, इसके लिए आप पुली के लिए डायरेक्शन लिखना चाहते हो, क्या होगा जरा बताओ, अपवर्ड या डाउनवर्ड,
डाउनवर्ड।
डाउनवर्ड होगा, क्योंकि तभी तो खींचेगा ना, दिस इज जस्ट ट्राई टू पुल इट। इस वाले पुली के लिए क्या होगा, जैसे ये पुली है, इस पुली में एक रोप ऐसे लगा हुआ है, दो रोप ऐसे लगा हुआ है, इसमें किधर होगा टेंशन बताओ, टेंशन देने के लिए आपको खींचना पड़ेगा ना, आर यू गेटिंग माई पॉइंट?
नो सर।
हाँ,
नो सर।
अरे अरे भाई, किसी भी चीज को खींचोगे तभी तो उस पर होगा, आप इसको इंडिपेंडेंटली देखो और इसको इंडिपेंडेंटली देखो, डोंट ट्राई टू सी दिस एंड दिस टुगेदर, आर गेटिंग माई पॉइंट?
ओके सर।
आप देखो, ऐसे देखो, मैं आपको दूसरे ढंग से समझाता हूं, एक रोप है, ठीक है, इस रोप को आप इधर से भी खींचो, इधर से भी खींचो, ठीक है, आर गेटिंग माई पॉइंट?
यस सर।
तो बीच वाला किसी भी एलिमेंट में इधर टेंशन होगा और इधर टेंशन होगा, यस
यस यस सर।
तो ये दोनों एक दूसरे को तो कैंसिल करता जाएगा ना, फिर से एलिमेंट लोगे, फिर से क्या होगा, ऐसे होगा ऐसे होगा, टेंशन एक दूसरे को कैंसिल कर देगा ये दोनों, फिर इधर वाले को ऐसे होगा कैंसिल कर देगा, यस या नो?
यस सर।
लेकिन लास्ट वाला जो पॉइंट मिलेगा उसमें तो एक ही डायरेक्शन मिलेगा ना, इन दिस लास्ट पॉइंट यू हैव ओनली वन डायरेक्शन, इजंट इट?
यस सर।
सो नाउ अब आप यहां पर देखो, इफ यू आर, अगर आप इसमें टेंशन देना चाह रहे हो तो आपको तो खींचना पड़ेगा ना उसे, यस?
यस सर।
जब आप
Yes, sir.
खींचोगे तो इसको क्या ऐसे खींचोगे तो टेंशन मिलेगा, बताओ, टेंशन देने के लिए तो ऐसे ही खींचना पड़ेगा ना,
ओके सर। ऊपर
Sir,
खींचना।
please explain in English, sir.
सॉरी,
I didn't. Can you explain in English, sir?
what I am trying to say, if you want to give the tension you have to pull the thing na, so how you will pull it when you will give the force in the opposite direction, isn't it?
Yes, sir.
So
Yes, sir.
in the same time, if I want to give the tension into this rope or this string, what I have to do, I have to pull na, then this will be the thing, this will be the thing, are you getting my point?
Yes, sir.
Okay,
Yes, sir. Yes, sir.
okay,
Sir, if here, how we calculate A naught value, sir?
sorry,
A naught value, how we will get?
sorry, your voice is not audible.
A naught value, sir. Hello, sir.
Hello, ha A naught value, A naught value,
Yeah. Yes, sir.
A naught value is not needed na, you have just assumed that its acceleration of whole this thing is moving with A naught in opposite direction, okay?
Yes, sir. Yes,
And
sir.
when it is moving upward direction with A naught, then this is moving with the same acceleration in a downward direction. Are you going to understand this thing?
Yes, sir.
Okay, and so why we have written A naught is equal to A1 plus A2 by 2, And here, this A naught, this same A naught in a minus sign, you have written A3 plus A4 by 2. So that means you can equate these two things. Are you getting my point?
Yes, sir.
Then you will get A1 plus A2 plus A3 plus A4 is equal to 0. And hence, these two pulley is massless. There is not any role to write the equation of motion. Okay?
Okay, sir. Okay, sir.
Are you getting my point?
Yes, sir.
This will only tell you that this tension, this T is equal to 2 times T1. And this will just tell you about this information. It will not necessary to find the what will be acceleration of A naught. Are you getting my point?
Yes, sir. Yes,
If you want to find the acceleration of A naught, then what you will find? You will find first A1 and A2, and you can get the value of A naught. Isn't it?
Yes, sir.
Okay. Okay. Let's go to one more problem. है ना? एक और problem देखते हैं. Just a minute. So suppose this is a fixed line and there is one pulley and there is another pulley, and then you have mass M, and here is also mass M1. Okay, and this has mass M2, and this is fixed here. So now rope is something like this. Are you getting my point? Let's say this distance is some h, and this distance you can assume negligible. Okay. So now, and this is a same rope. This is same rope. Okay, this is same rope. So now, what will be relationship of acceleration between M1 and M2? What will be relationship of the acceleration between M1 and M2? Suppose its acceleration is A1, its acceleration is A2. Now it will go downward, then obviously it will go upward, isn't it? So what will be the acceleration between these two? What is relationship between A1 and A2? Chalo, try karo, take your time.
तो सेकंड पुली के फिक्स है.
This is fixed. This is fixed. Okay. This can move up and down. ये नीचे जाएगा, then this will move up. Okay. If it will go down, suppose it will go down, then this will move up. Okay. It will depends what is the mass. Just try to figure it out. Sorry.
सर A2 equals to 2A1.
A2 is equal to
equals to A1.
2A1.
same have both have same sign.
A1.
नहीं सर सेम साइज नहीं है सर.
So
हेलो सर.
value is same, but sign
Yes,
is
sir.
opposite.
Different.
Okay.
Yes, sir.
Very good. So you have to just write the opposite sign, na? Which is very important. So suppose this is x1 and this distance is what? x2. Now, what is your equation of, what is your length of this particular rope? What will be length of this rope? x1 plus, what will be this
X2 minus
distance?
H.
Pi
Pi r.
r. Very good. What will be this distance? x1 minus h. Yes?
Yes.
x1 minus h. plus what is this distance? Pi r. What will be this distance? X2 minus h.
X2 minus h.
And that value must be equal to what? L. And now you can differentiate twice. When you will differentiate it twice, then what you will get? X1 double dot plus X1 double dot plus X2 double dot must be equal to 0. So 2A1 plus A2 must be equal to 0. So A1 is equal to minus A2 by 2. Okay. Now, what will be direction of tension in this case? बताइए क्या होगा tension? Upward or downward?
Upward.
Upward. Very good. For this pulley, what will be direction of tension?
Downward.
Downward. Very good. Downward. For this mass, what will be direction of tension?
Upward.
Upward. Tension will be same or different?
So same.
Same. Everywhere
Same group,
tension
same.
will be same. The tension is same. Okay. The tension is same. Okay. So now you can write your equation of motion and you can easily solve it. आप कैसे कर सकते हो? What will be equation of motion for this one? M1G minus 2T. So look at here. This is 2 tension is pulling and which is balancing this M1G. M1G minus 2T is equal to M1A1. Second equation. What will be this thing? M2G minus T is equal to what? M2A2. And now from here, you can, the third equation is this one. So this is your equation 1, this is your equation 2, and this is your equation 3. And these three equations you can solve it together and you can find what is the value of A1 and what is the value of A2 in term of these two masses. निकल जाएगा क्या?
Yes, sir.
Everyone? Okay?
Yes, sir.
Okay. So just try to calculate this mass and tension, whatever you want to calculate with yourself. Okay? I am not giving this time in the class. ये आप खुद ही calculate कर सकते हो. Now everyone is comfortable with the direction of tension?
Yes, sir.
Everyone is comfortable with the direction of tension? Comfortable हो ना?
Sir, can you explain the directions of tension?
Look at here. Why don't bother about tension? See this thing independently. See this thing independently. See this thing independently. Now you are okay?
Yes, sir.
Okay. Now, when you are watching this particular thing, the mass is pulling it downward.
Yes, sir.
Yes. So for the tension, what you will do? For the tension in rope, you will pull it upward or downward?
Upward, sir.
Upward. So why this is upward? Okay.
Okay.
Okay. Now, for this mass is going downward. It is pulling it downward. So
Yes,
if it
sir,
is pulling it
understood.
downward, for the tension, what you have to do? You have to make it upward or downward?
Upward.
Upward. So this is also okay. Are you getting
Okay.
this thing?
Yes, sir.
Okay. Now go to this particular pulley. Whether it is not necessary to calculate this particular thing, but for the concept of tension, you want to give the tension into this particular string. So what you will do? You will pull it downward or pull it upward?
Downward.
Downward. So it is downward. Are you getting my point?
Yes, sir.
So you have to think independently. Don't think that this tension and this tension is going to cancel out. This is the
Okay, sir.
most important confusion to the students. Are you getting my point?
Yes, sir.
Is that clear?
Yes, sir.
Okay. So this tension is for this particular mass, this tension, and this is the same value is there, and this is the direction for this particular pulley. And suppose there is one rope is also there. This is suppose mass M1G. What will be tension into this string? Upward or downward?
Upward, sir.
Upward. Okay. For this mass and for this pulley?
Upward.
Upward. Here,
So
in this
downward.
string.
It's not seen to me, sir.
For this string, make it little bit larger. Suppose this type of thing is given. Okay. Now, for this mass, the tension will be upward or downward?
Upward.
Upward. For this pulley, the tension will be upward or downward?
Downward.
In this string?
Downward, sir.
Downward. Now, this is for this particular pulley, this is for this particular mass, this is for here, and this is for this particular pulley. Are you getting my point?
Yes, sir.
Every time you are just pulling the thing. This is the most important thing for the tension. Okay?
Okay, sir.
Okay.
Thank you,
Chalo,
sir.
I think you need some more practice on this particular tension. So I will take up some more problem in the next class. और कल की क्लास में हम लोग इसे finish करेंगे. ठीक है?
Okay, sir.
Okay. So just try to practice this one and फटाफट करके जरा मुझे solution भेजो. मैंने 2 क्वेश्चन का बोला था ना solution भेजने अभी.
Yes, sir.
Okay? Everyone, please. एक या 2 लोग करते हैं तो selection भी 1 या 2 का ही होगा. Okay? This is very important in online classes that you have to do homework and at least post it such that I can see where are you people lagging. Okay? Chalo. Thank you.
Thank you, sir.
Thank you, sir.
sir.